Emergency transmission received.
Professor Beaker, are you there? I seem to have run into a spot of trouble.
Dr. Vex, are you all right?
Well, I was on an archaeological exploration in the pyramids of Pythagoras, looking for the long-lost golden ratio triangle. After much searching, I've located the artifact. Removing the triangle from its resting place seems to have triggered a booby trap. I'm stuck in a chamber and there appears to be some sort of hieroglyphic riddle blocking the exit.
X-B.I.T, any ideas what it says?
Translating hieroglyphs. Translation complete. Welcome, traveler, to your final test of wits. Before you stand 3 paths, one to freedom, the others to endless pits. Take your pick, good soul, but be warned whichever path you choose. A different path to entrapment will be identified, giving you less of a chance to lose. All right, dear fool, now comes the trick of the second choice at hand. Either head down your first chosen path, or switch to the other opening that doth stand. Look out, traveler, you have been told. Just hope you survive the test and keep your triangles of pure gold.
Professor Beaker, it seems like a 50-50 gamble. I can't leave the rest of my time on Earth to chance. I need your help. What should I do?
Transmission terminated.
Dr. Vex? Dr. Vex, are you still there? Vex! X-B.I.T, we need to act fast. Dr. Vex is in trouble and we're his only way out. We need to get researching.
Perhaps some background on probability would be helpful. I'll look up what I can in the mainframe. Top results. Probability. The relative possibility that an event will occur as expressed by the ratio of the numbers of actual occurrences to the total number of possible occurrences. Subfields include 1. The probability of flipping a coin. 2. The probability of rolling a die. 3. The probability of drawing marbles from a bag. 4. The probability of picking a playing card.
Gee whiz. 1 second, X-B.I.T, I need to... yes, I found it. Let's learn more about the probability of flipping a coin. That way we can run experiments with this coin I have here.
Good thinking, Professor. Looking up coin experiments. Results found. Flipping a coin is the most basic experiment one can run in the field of probability. When a fair coin is flipped, there is a 50-50 chance of getting a heads or a tails.
Let's test it out. So if I flip this coin, I will either get a heads or a tails. And if I flip it again, I still have the same chances.
That is correct, Professor. The property of coins that you are referring to is called independence. The outcome of one event has no bearing on the outcome of the next event.
Interesting. But what if I want to know the probability of a sequence of events? In Dr. Vex's case, he's choosing a sequence of paths. He chooses one path at random and then chooses another path by either switching paths or sticking with the first path he chose. It seems comparable to, say, flipping 2 coins and testing the chances of getting a heads and then a tails.
Testing proposed experiment. Computing virtual simulation. Total possible outcomes of flipping 2 coins. Heads, 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 tails, tails, heads, tails, tails. 1 out of 4 outcomes will produce heads, then tails.
So 1/4. Hey, wait a second. I think I get it. There was a 1/2 chance that I got a heads on the first flip, and a 1/2 chance that I got a tails on the second. So 1/2 times 1/2 equals 1/4.
Yes, Professor. Perhaps it might be easier to visualize this information in a probability tree like this.
I guess that does make it easier. All I need to do to determine the probability of an event, say, heads, is to follow down the tree and multiply the probability of the connecting branches together. Hey, X-B.I.T, can you make a probability tree for flipping 3 coins?
Sure thing, Professor Beaker.
So let's see. What would the probability be of getting exactly 2 heads? I can either get heads, tails, heads, or tails, heads. Each are equally probable with a 1/8 chance, so the chances of getting exactly 2 heads is 3/8.
Correct, Professor. This is known as conditional probability, the probability of an event occurring, given that another event occurred.
All right, X-B.I.T, we're running out of time. Let's see if we can apply what we've learned so far to help Dr. Vex. So the 3 paths are kind of like a 3-sided coin, with a 1/3 chance of freedom and a 2/3 chance of the trap. Assuming Dr. Vex chooses a path at random, we then need to look at the conditional probability of this freedom or entrapment given his decision to switch or not. Let's assume he sticks to his gut and doesn't switch. So we know one of the paths to the pits has been blocked. If he chose an escape path first, he has a 100% chance of escaping and a 0% chance of being trapped. If he chose the trap path first, he has a 0 chance of escaping and an 100% chance of being trapped. Calculating down the tree, he has a 1/3 chance of escaping and a 2/3 chance of being trapped. Oh no! Dr. Vex! He's more likely to be trapped forever than escape the pyramids!
Professor Beaker, you have only checked the probability of Dr. Vex refusing to switch paths. There is still a second option. Look what happens to the tree if we simulate Dr. Vex switching paths.
By golly, X-B.I.T, you've done it! If Dr. Vex switches paths, he has a 2/3 chance of escaping. We need to get this result to Dr. Vex as soon as possible. He needs to switch.
Beginning video communication.
Dr. Vex, we've done the calculations. There's still some chance involved, but if you switch paths, you have a better chance of getting out of there. Are you sure, Professor? Probably. Here goes nothing. I guess missing all of those math classes really added up. Thanks, Professor. I owe you one. Don't thank me. Thank X-B.I.T, the power of probability and maybe a little bit of sheer darn luck.